Hello and welcome back to Machine Learning. I'm Jovita Christie, and in this video, we are going to talk about logistic regression, which is one of the methods for binary classification in machine learning, and we are going to see how to evaluate it. So let's begin. Now, for implementing logistic regression, first we require all of these libraries, and you need the NumPy library, the pandas library. We will be needing the linear model from sklearn, so you can import it like this. Once all your files are imported, you can read the CSV file that you need, and this is my file name. So the file contains data about people's heights and weights. And it tells you whether a person is male or female on the basis of their height and weight. So this is real data given about people's heights and weights and whether or not the person is a male or a female. So if you look at the data, if you just open it, here I'm just printing out the first 5 rows, but if you open it, you will notice that in the male column, there is 1. 1 indicates that the person is male, and there's also 0, which indicates the person is not male, in which case the person is female. So this is how it is organized. To open the file, you simply have to pass the file name into the read CSV function of pandas, which is done like this, pd.readcsv file name. And this is the whole pandas creates a data frame, which we are storing in a variable called df for data frame. And when you write df.head, it's going to just print out the first 5 rows of your data set. So that's what it is here. And if you just do df.shape, it will tell you how many rows and columns are there. So there are 10,000 rows in this data set and 3 columns. Okay, let's quickly plot this data. So this time I'm just going to use the Seaborn library. So you just have to write import Seaborn as SNS and sns.set. So you're all ready to print a nice graph or a scatter plot using Seaborn. Matplotlib is not required right now. So if you don't import this, it is all right. Now to actually show your data, what I want to do is create a scatter plot of height versus weight, and then color all the females with one color and all the males with another color. So to do that, we are going to use sns.scatterplot, where you have to pass the values for x and y. So I want my x-axis to be height and the y-axis to be weight. Okay. Remember that these two are the names taken from your data set, so the spelling has to match exactly. So this is height from here, this is weight from here, and you can specify how you want to color your graph. So I want to color my graph according to the column male. So for all different values of male, I want a different color. Now there are only 2 values for male, 0 and 1. So it will give me 2 colors automatically. That's why I've written hue equal to male. And you also need to specify where the scatter plot gets the data from. So the data is available from the data frame df. So you just write data equal to df. And when you run this, you'll just get your scatter plot. So you can see that there is a clear bifurcation happening right here somewhere. All these bottom values are blue, and blue stands for male value equal to 0, which means all these blue are females, and all the orange ones above, they are males. Okay, and these are all the heights, and the y-axis contains all the weights. So this is a simple scatter plot just to show to you how the data looks. Now, once we have our scatter plot ready, and once we know what the data looks like, we are now ready to apply our logistic regression model. To do that, we are going to separate out our values into x and y. Now, logistic regression allows you to have multiple x values to predict one y value. So in our case, we have two X values, height and weight, to predict whether the person is male or female. And this is an example of binary logistic regression. So, which means the prediction class can have only two possible values. And that is true for us because what we want to predict is male and it has only two values, 0 and 1. So now that it's ready, we can apply it. So we are just going to separate X and Y. So X is height and weight. To get height and weight, you can use the iloc function, df.iloc, and we want all the rows. So just put colon, but from the columns, we only want the first two columns, height and weight. So that means column 0 and column 1. To do that, you just specify the indices 0 to 2 because it does not count 2. And then just write dot values. So everything is, all heights and weights are stored now in X. And we'll create another variable Y. And in this, we are going to store our prediction values, which is the male column, which would be our second column, 0, 1, 2. So the index is 2. So we'll just pass, we want all the rows, but we just want the second column, and that gets stored in Y. So these are X and Y bifurcated. Our next step, as in every machine learning algorithm implementation, is to split our data into training data and testing data. And to do that, we are going to get this library, sklearn.model selection, and import from there the train test split function. This function returns the data to you in this order. It gives you X train and X test first, and then it gives you the Y train and Y test. So first it splits X, then it splits Y. And the ideal test size is 30% and or 20%. So we are going to use the train test split function, pass X and Y, and test size is 0.3, which means 30%, and random state equal to 0. You could specify any number here. And now we are going to create our regression model. To do that, we will be using linear regression dot logistic regression because that's what we want to implement. And we will store this in our CLF. So CLF is a kind of an object. So CLF is a class. I've written CLF because it's a classifier and it's an object. And using CLF now, we can fit our training data. So we pass X train and Y train and fit it. And this is the fitted model. And once the model is fitted, we can make predictions now. So to test our model, we are just going to pass X test and not Y test because the model will generate Y test. So you just have to write clf.predict, and that would generate Y test values, which we are storing in prediction. Now, if you try to print prediction, this is what it will look like. It will print values of zeros and ones. So what it's telling you is that this first row is supposed to be female. The second row is supposed to be this. The third row is supposed to be this. So that's what the prediction says. And of course, these are randomly distributed. So it's not like exactly like your data set. It's not in that order. But that's what prediction tells you, zeros and ones. Okay. If you want to check with your own height and weight, you can pass. Now this model, this data set contains heights in inches and weights in pounds. So if you want to check out your own height and weight, you can pass your own height and weight and get the prediction. So once you've passed the height and weight variables, to predict, you just have to write clf.predict and pass height and weight. And remember to do it this way, because this model expects a two-dimensional array. That's how it's programmed. So you have to give a two-dimensional array. And to do that, you have to pass this in this manner. So you need to have the round brackets for the function itself, then the box bracket and round bracket to make it a two-dimensional array. And then you will pass the height and weight. And whatever is the prediction will be stored in this variable prediction underscore individual, which will be either 0 or 1. If it's a 0, we just want to store in the result variable male. And if it's a 1, Sorry, actually, it should be the other way about. If the prediction is 1, then we want to store the result male. Otherwise, we want to store female. So that's a slight mistake over there. I'm not correcting it now because I'll have to run the whole program again. Never mind. So then you can print out what is the result, and it will show you if the person is male or female. Okay, in this case, it's printing female, which means I think that means it's male. So this is how you can predict individually for any kind of height and weight that you want. Now let's talk about evaluating the model. So we have studied several techniques in our previous video about how to evaluate a classification model, and we're going to apply all of those techniques here. So let's first talk about the accuracy score. If you need to know what all these terms are, you can refer the previous video. I'm not going to explain what is accuracy, what is precision, and all that here. I'm just going to show you how to calculate it. So within Python, we have sklearn.metrics library from where we can get the accuracy score function. And in that, you just have to pass your y-test and your prediction. So y-test are the actual values. Prediction is your value predicted by the model. And if you just pass those two, it will give you the accuracy, which is 0.918666. Okay, so that is your accuracy. Error rate is simply 1 minus accuracy. So you can just do 1 minus accuracy and get your error rate, which is 0.08, which is very less. Next, let's talk about how to create a confusion matrix. So again, we can get from sklearn.metrics, we can import the confusion matrix function, to which once again we have to pass y-test and prediction. And we'll store the matrix in CM and print out CM, which will be a two-dimensional array that contains these 4 values. Okay. Now, out of these 4 values, the value at position 0, 0 is going to be true negative. Okay. That means 1385 is going to be true negative. The value at position 0, 1, okay, 0, 1 is this position. That will be our false positive. So 104 is false positive. The value at position 10, which means 140, is going to be false negative. So we are storing it in Fn. And the value at 11, which is 1371, is going to be your true positive. So we are storing it in TP. And once that is done, let's print out all 4, TP, Fn, Tn, and Fp. And so we have all these values right here in our confusion matrix. We can use this to calculate all the other evaluation measures that we saw earlier, okay, in the previous video. Now, just to show you the number of values in y-test, we are just doing y-test.shape. So you can see 3000, which means y-test contains 3000 out of the 10,000 values, which is fitting because we mentioned that we wanted 30% of the data to be used for testing. Now let's calculate sensitivity. We know the formula Tn divided by Tn plus Fp. So just put that in and you can get sensitivity of 93% here. Now specificity and recall and true positive rate, they are all one and the same. So the formula is true positive upon true positive plus false negative. Okay, and I'm just going to save that into my recall variable as well as TPR for less confusion later. And this is what specificity is, 0.907, which means 90%. Okay. Next, we also studied the Kappa value, which kind of balances, your accuracy. It balances out the accuracy. Because sometimes accuracy could be just a coincidence, right? Because coincidentally, some of the values were, some classifications were correct. So to prevent that from happening, and if you want a better measure, you could use the Kappa value, which is calculated in this manner. So first we'll calculate what are the total values. Total is of course 3000, we just saw it. So if you add all these numbers, TP, FP, Fn, and Tn, you will get 3000. Next, we calculate the proportion. So the proportion probability is calculated like this. You have to take TP plus FP divided by total, multiply that by TP plus FN divided by total, and add to it Fn plus Tn divided by total and Fp plus Tn divided by total. Okay, so multiplication of these two, and then addition of those two terms. And once you have your PPR, you can calculate kappa by using accuracy minus PPR, divide by 1 minus PPR. And your kappa is going to be 0.837, which is much less than accuracy. Accuracy was 91% almost. And this is only 83%, which is fitting because the kappa value sort of balances the accuracy. So that's why it's always going to be less than accuracy. So in our case, it's much less. Now to calculate precision, we know the formula is TP divided by TP plus FP. So just use that. You get 92% precision. If you want to calculate F measure, the formula is 2 into precision into recall divided by precision plus recall. So that's the formula calculation, and you get 91% almost. Okay. Now we are going to talk about the ROC curve, right, which we studied in the previous video. So if you want to make an ROC curve, you require TPR and FPR. TPR is true positive rate, FPR is false positive rate. So you can calculate FPR and TPR like this, but those will only give you two values. What you actually need is specific TPR and FPR for each data point. Okay. So right now what is happening is we are just calculating TPR and FPR using the formula. So TPR is same as, we just saw TPR over here somewhere. Yeah, so TPR is same as specificity. So we don't have to calculate that again. But FPR is false positive upon false positive plus true negative, which comes to 0.06. Okay. But here we are going to calculate, to draw the graph, we are going to calculate TPR and FPR slightly differently. First of all, we are going to import metrics from sklearn. We are going to import matplotlib because we want to draw a plot. Of course, I think imported before also, it doesn't matter. So we want to create a graph. That's why we are importing matplotlib. Next, we are going to use our classifier. So where did this CLF come from? It came from right over here, where we created an object of logistic regression linear model. So that's the same CLF. Now, using the same CLF, we are going to predict the probabilities of X test. So this is something different. When we are just predicting without probabilities, then we get a value 0 or 1, which means the model simply tells you that this person is male, this person is female. But when you're predicting with probabilities, that means the model is no longer going to tell you that this person is male or this person is female, but instead it will give you the probability that this is the probability that this person can be male. So you can just assume that 1 minus that probability is that the person will be female. So that's what we want. We want the probabilities, and using that we can calculate our false positive rate and true positive rate. Okay. So to do that, we are passing X test, and all probabilities get stored here. And this will, of course, be just one-dimensional, but we have to make our array two-dimensional for the model to work, and that's why we are doing this kind of a thing. And we are taking, from the probabilities, we just want one column. So we are taking that one column out and storing that into in these predictions. Okay. Next, we want to get our ROC curve. So you can use metrics.roc curve and pass into it the Y test values and these predicted probabilities, which will give you the FPR value, TPR value, as well as the threshold value. And once you have all these values, you can create your ROC curve. Remember that in an ROC curve, we are interested in AUC, which is the area under the curve. And so we are going to use metrics.auc function, pass into it FPR and TPR, and that would get your ROC underscore AUC ready to be plotted. Okay, so I'm going to give a title to my plot, receiver operating characteristic, which is the full form of ROC. I'm going to plot it. So I'm going to plot FPR and TPR. So FPR will be on my x-axis, TPR will be on the y-axis. Okay. There are a couple of things over here that you may not understand because this is something that you would learn if you studied Matplotlib library. So for now, you can just skip all these things, all these details. We're just creating a plot. Okay. So the legend simply means this, which is shown here. So we want it in the lower right corner, okay? And plt.plot, we are going to plot x and y axis from 0 to 1. And with red color, we want this line. And dash dash is for a dashed line. And we are also providing a limit. So x limit is 0, 1. Y limit is also 0, 1. And then we can give a label. So my Y label is true positive rate, X label is false positive rate, and then show the plot. So this is the plot. This is the red line that divides our graph. And this blue line is your ROC. And you can see this much is the area under the curve. So the area under the curve is 0.97, which is quite good.